Hello, my name is Fabian Strüfer and I'm part of the consulting team of EPLAN Software and Service. Our target, our mission, helping customers to succeed with EPLAN in the fastest way. How do we do that? With workshops. And one of our workshops, which is becoming more and more value for our customers, is product structuring based on the standard IEC 81346. We from EPLAN are totally convinced about the standard and the power to use it in the engineering process and also to use it with our software products. But to be honest, it's most of the time a challenge to convince customers to think new, to adapt the ideas in the engineering processes. It's a change. That is the reason why we thought about why shouldn't we invite a person who is deeply involved in that topic, creating norms and standards, and have the concept and knows it better than everyone else. That is the reason why I'm happy to have with me Henrik Baslav, founding member of the ISO IEC 81346 for structuring principles and CEO of Systems Engineering. Henrik, a warm welcome.
Thank you very much. It's a big pleasure for me to be here with you today.
Henrik, a few words about you?
Yeah. I have a background in electrical engineering and I'm also certified at expert level of systems engineering. And what we do for a daily living is that we teach and introduce common language for different kinds of disciplines within engineering. That means creating a common language for electrical engineers, process engineers, program engineers, and civil engineers, etc.
That background fits perfect to our business, electrical engineer, process engineering. That is our stuff. And yeah, great to have you here.
Thank you.
Henrik, today we like to demystify the concept behind systems engineering and the IEC standard 81346 for structuring principles. And we would like to see the really benefit for companies who managing engineering processes. So my first question to you is, why is there a need for system engineering and structuring principles?
Thank you very much for the opening remark and thank you for the opening question. First of all, I would say we use that as a method to create what we call a common language. And there is another industry where they already have such a common language which is necessary for them to work together and play together. And that's within music. I mean, can you imagine that we invite 4 musicians to come into this room and play with us and they just come in and say, you sit down and you just play. Come on, play. Difficult. And it's a bit difficult, isn't it? And they would probably, start jamming and say, yeah, we know we are quite good at our instruments and we are quite good at what we do, but how do we actually play together? Within the music, they have something called music keys, so they can actually sit down and play together. So if we give our 4 friends some keys and notes here, they can actually sit down and play together because they have a common language. And that's the same thing we want to try to achieve with the way we're going to do things today.
Okay, that is a really nice and easy example. So to understand it or underline it, the norms and standards are the notes for our engineers.
You can put it that way, yes.
Okay, Henrik. The second question was then, how can companies start to implement this system thinking to get this common language?
Well, as you said yourself, the premise for getting the common language is that you need to think in systems. So there's a premise you need to buy in on, and that is system thinking. Now, what does that mean? Let's take a more human example. Let's take ourselves as a human being. If you want to have some fun some afternoon, you could go try and Google human systems and see what comes up. You will find out that there's actually well-defined systems in ourselves. For example, we have a digestive system, we have a nervous system, we have a skeletal system, and so on and so on. So in fact, if you try to find out what a human being is, you will meet the word system 11 times. It's 11 systems we comprise of. It's a way of handling a complex thing like a human being. And it's the same technique we use when we go and want to have a look at, for example, a platform offshore, or if we want to have a look at an aircraft. It's the same thing. Yeah. I think the new thing here is that for electrical engineers, thinking in systems is not a new thing, but the new thing is everybody has to think in systems. So one of my favorite examples is, in fact, the steel structure of the platform is a system of itself. And if you look at the wing for an aircraft, that wing is certainly a system of itself as well. So that's what you need to think of. It's not just electrical engineers, but also mechanical engineers, civil engineering, architects, programming, who has to think in systems, and they have to create the common language based on that one as well.
Okay, can we go a little bit deeper in that thinking what you explained?
Yeah. Maybe we need to define what the system is. As a certified in systems engineering, we believe in the definition of systems taken from the ISO 15288 standard. That's the standard for systems engineering. And what the definition says is that a system is a combination of interacting elements organized to achieve one or more stated purposes. Now, that always sounds a little bit complicated, but definitions are very important to understand what we are talking about. But let's be a little bit more practical, and let's go have a look at a practical example. For example, if we look at a computer mouse. So if you look at a computer mouse, which everybody is aware of what is, in fact, what the standard says is that if you take a click button left and click button right, the chassis, the batteries, the sender, and the receiver, you put all that together, and by default, that becomes a system. So in fact, every day you touch a computer with a sender receiver, you're actually operating a small, what we call a component system. And that's the basic for the next steps.
Ah, okay. Can you show us a little bit more when you structure it, perhaps? Yeah. Nice example.
Okay. So let's take one step even further. So of course your clients would say, yeah, but what we do are big plants and big machines. It's too complicated for that. What systems engineering says is that the only way to achieve an overview is that you need to break a system down in system elements, that you recursive go down and break down until you reach the level that makes sense for you. And that is the trick behind systems engineering and system thinking, is that a system comprises of system elements, which again comprises of sub-elements and sub-elements and sub-elements again. And it works for everything. It works for all the electrical circuits, for the mechanical circuits. It works for the building industry, for walls, for floors, and everything you want to imagine at all.
Okay, what does RDS mean?
Now we are getting closer to the 81346 standard today, which we wanted to demystify, didn't we? So the point here is that when you have decomposed your systems, you need to put a label on it so you know what kind of systems you're actually looking at. And here comes the RDS, also called the 81346 standard series. What we are talking about today is the ISO IEC 81346 standard series. And all you need to know up front is a double logo ISO IEC standard. That means that mechanical and electrical engineers are good friends in this one. And furthermore, it's too complicated to say 81346.
Okay.
So we have this general abbreviation, so we just call it RDS, which means Reference Designation System. So to put it more gentle, it's a system that you use to designate other systems with.
Okay, RDS means the same like 81346.
Yeah, it's
just
the same.
Easier.
It's much more easy to say.
Can we go a little bit deeper how it works? Have you an example for that?
Yeah, we have just released a relative new edition of the standard. The standard is maintained very often. And what we found out when we did that one is that we need a way to organize our systems in a triangle so they are more easy to use. So the point is that we found out that to make it easy enough for users to use it, we have created this triangle. And what you see in the triangle is in the bottom we have component systems. In the middle we have what we call technical systems. And the top we have what we call main systems. Okay. And that means that you have different kind of systems that we look at different level of granularity. Let me give you a practical example from the playground world.
Nice. Okay. Yeah.
Yeah.
Nice idea.
Yeah. Lego, like you and I played with when we were kids.
Yeah, it remembers me to the childhood.
Yeah. So the thing here is that when you look into the Lego stuff as well, there you can have different components in the bottom, and you can have things that you can aggregate them to, and you can aggregate them further on as you go. And I think the point here is that, for example, if you look in the bottom, we have different kind of component systems, the gate, the staircase, and so on, and the window, that you can aggregate and put into different kind of technical systems. And when you have made these technical systems, you can put them into different kind of main systems as well.
Are these steps or these 3 levels fixed?
That's a very good question, which we often get. And first of all, I'll say no, certainly not. It's just a library we pick from.
Okay.
Maybe you recognize also behind your customers that very often people have a fixed tag number in their systems. And in fact, that tag number is actually putting a limitation of how you should think of things. The 81346 standard series is quite clear on that one. It says that you shall have a tree-like structure, which means there's no fixed notation for it. Very often when we introduce that kind of thinking, people say, but I like a fixed notation because now I know exactly what everything means. So what we did when we investigated that, we said, all right, what people actually really want to do in that notation stuff is to have a recognition thing of what they're looking at. So we decided to replicate that one as well. So when we went for the standard and made some new tables in it and updated them, in the triangle, we have decided to show that the flexibility can be maintained as well, exactly as you have with Lego bricks. You can put big Lego bricks into smaller Lego bricks and so on and so on, whatever you like to do.
Okay, okay. That is what our customers need and always ask for in our workshops. Yeah, really nice. Okay. What does these letters stand for in these 3 levels?
I'll show that in a moment. But before I show that, I would like to show you that we have a technique of how we put systems into systems. So the point here is that you can have a technical system which is a part of a main system. In this case, it's a big oil and gas system. And within that technical system, you can aggregate your component systems as well. The trick is to avoid having always 3 levels. You can also put a technical system inside a technical system.
Interesting, okay.
And you can put a component system in a component system.
Okay, that allows you to have more than 3 levels.
Yeah, so you can have 1 level, 2 levels, 3 levels, 4 levels, or 5 levels. Now, to achieve this recognizability, so people, when you actually work with it, can see what kind of level am I working with, we have decided or investigated and found out it's very easy. So if the top level have a 1-letter code, if the mid-level have a 2-letter code, and if the last level have a 3-letter code, it's very easy to recognize within a string what kind of systems you have put together and what they are about.
Perfect. Perfect idea, yeah. I like that.
So 1 to 3-letter code, flexible structure, and you put systems together. That's the idea.
Okay.
By that technique, you can build a complicated thing like an offshore platform. You can build an aircraft, or you can actually build a house, or whatever you like, a big plant, distribution systems, whatever you like. This technique works for everything.
Do we also have an example for our participants and customers, perhaps with schematics or PNIDs, something like that?
Yeah. Have you ever wondered of the mystery that electrical diagrams have a motor which has 1 tag number, and then you have a PNI diagram where it has another number? Have you ever come across that scenario?
Most of the time.
Most of the time, right? So for sure they don't have the same language in PNI diagramming and electrical diagramming.
History, I mean.
Yeah, history. So the point here is that if we go and have a look at what an electrical diagram and a process diagram is, and look at the different kind of ways it should be done, is that what you can see I've created for you here is I've created a new slide where I show in the middle a system breakdown based on, and you can see here we use the 1-letter code, we use the 2-letter code, and we use the 3-letter code. And if you look closely, you can also see we actually have 3-letter codes inside 3-letter codes as well to make a system breakdown that makes sense.
Yeah, really nice example.
Now, in this case, we have the pump system, which is the orange thing, when you look at the orange thing. So, in fact, we have replications of the pump system both in the electrical diagram and in the PNI diagram. And as you can see inside that one, we also have a motor MMA1. So the trick, of course, is that you create the system, the reference destination system in the middle first, and based on that one, you give the name to the motor in your electrical diagram and to the electrical motor in the PNI diagram, or to the PNI diagram first and vice versa. It doesn't really make sense, make any change what you want to do. But I think the new thing here is that the numbers are born in the reference destination system and given to the diagrams and not vice versa.
Okay, now you catch me, and I hope also our participants. I want to know more. So I'm convinced, and now I like to know, are there or what kinds of tools or techniques are there to implement system engineering like you explain it now?
We are practical guys, so we also decided to show you a little example today we could actually work with. But before we do that, I need to show you this little drawing here first.
Yeah, perfect.
The thing is that the title from our speech today is how functional engineering can actually make you more efficient. And what the standard says is that you cannot just make a system breakdown based on the 1 and the 2 and 3-letter code. We need a third leg to walk on, so to speak. And that is that you need a prefix in front of it so you know what kind of thinking you are using when you make the breakdown.
Yeah.
And default, the standard says that we have several ways of looking at that. I just selected the 3 most common, that you also have an EPLAN. We have a functional aspect, and the functional aspect defines that you think in functionality only. We have the minus, which is the product aspect, which tells you that you think in how things are constructed only. Mm-hmm. And then you have the plus, which tells the user that things are only made by location. Mm-hmm. Okay. So we need this way of filtering out information, so to speak. So today we are only talking about the functionality of a thing, and therefore we use the equal only to navigate in a functional orientated system breakdown. And I think this is what this talk is about, that you have a functional orientation. One thing I would like to add is that based on practical daily life, we have found out that some engineers prefer to work in functionality. For example, myself as an electrical engineer, but also process diagram engineers, they work very much in functionality, whereas civil engineers and the people who produce plants and things like that, the physical layout, prefer to work mainly in the product-oriented structure, things you actually physically build together. So today we only focus on the equal only, and by doing so, we are going to maybe have a closer look at what electrical diagram is about.
Yeah, exactly. From my point of view, or my experience, is that the location and the product aspect is really known to our customers, but that is interesting about the function aspect. Do we have an example with schematics?
We have. Before I came here, we had a chance to have a look at some classical ways of doing electrical diagramming. And what you see here in front of you is a classical way where you, on the first kind of pages, you put together the power circuits. So in this case, we actually see the motor and the pump for the power circuits. And typical on the next pages, you will see the different kind of control equipment that actually controls it.
Oh, nice.
And flying down here, I was thinking about why is it like that? And I think it's very banal. It's from historical reasons. Mm. When I originally was trained as an electrical engineer a long time ago, the first thing I was taught is that you need to put the power circuits on the front page, and then you can put the control circuits on the next pages.
Yeah.
And when you have a small complexity, it's okay to do it like that. But I think most companies today have faced that complexity is growing, and thereby it gets quite complicated to navigate in that way of doing it. So I think one of the things we want to show here is we should maybe reorganize. As you can see here, if we should introduce system thinking on your existing way of doing it, there will be a lot of manual work.
Mm-hmm. Yeah, I noticed that because, yeah, to be honest, we speak about benefits, and if we tell our customers that he has to mark now his devices with a structure box with equals to get this a common language, I think I get some trouble with my customers.
We can't have that, can we?
Do we have a solution for that? I mean,
yeah, and I took the chance to make a proposal for how you could do that. And I think the price you have to pay, if you think that common language is a good thing, and you want to do something, it comes with a price, and the price is that you need to make a change. It doesn't come for free, so to speak, but it will make you much more efficient. And what you have to do is that you have to reorganize the way you actually document your systems. Yeah. And you need to actually, in this case, I'll just do a practical way. What we did here was we collected both the power circuits and the control circuits in one page. And then, as you can see, we put a simplification rule around it to say this is the motor system. And inside that, you both find the power circuits and the control circuits. What you achieve with this way of doing it is that you actually collect very easily within a very close environment, maybe just a few pages next to each other, the control circuits and the power circuits. It makes it very easy to multiply the different kind of systems. It makes it very easy to navigate in, also for findings and for maintenance and things like that. Of course, it's more difficult to build a cubicle based on this one, but I know from EPLAN that you can make a lot of very nice extractions and questions and queries, so you can get a lot of information the other way out. Yeah, so I'm totally convinced that brings us so many benefits. You said it, templates. Yeah, I think that is also a nice view for maintenance persons. Yeah, indeed.
And also the topic configuration of schematics is much easier with this style of schematics. And it's really, really interesting that you see it in the same way like we tell as our customers. Really nice, really nice. So, Hendrik, when I'm really interested in this topic, where can I read more about this?
A few hints. First of all, I would say that we have a homepage, 81346.com, that we operate. And if you go to that one, you can sign up for newsletters, and there are some free stuff you can download. I've made a handbook. This is the 4th edition in English, and it has just recently been translated to German as well. So there is, in fact, the same handbook available both in English and in German, and other languages are coming. You get it by go to the 81346.com, and you click on the handbook, and it will be transferred to the Danish Standards web shop, where you can purchase it either as a PDF for download or as a hard copy that they will send for you. Furthermore, just a few more things. If you want to see how we work with common language and the clients that we work with, go to our homepage and visit Syseng.dk. You can see who we are and what we work with. And then finally, but not least, I would say a lot of videos are actually popping up on YouTube about 81346, not just by us, but also by users of it who try to explain what it's all about. So if you go to YouTube and if you try to search for 81346.com, then you will see that a lot of instruction videos and practical guidelines and hints are coming up, not just from us. Our video is called It's All About Creating a Common Language.
Perfect. And we also have an example in our software sample project. Have a look in this if you are interested in. So thank you very much, Hendrik, for changing your experience with us. And now it's time for questions, the audience.
I look forward to that.
Let's have a look. Okay, so questions are arrived, and one question is, how much is system engineering users worldwide? Used worldwide, sorry.
How much are systems engineering used worldwide?
Yeah.
Well, I think it's difficult to put a number on, but it's a well-known discipline. Systems engineering as a discipline they have an environment around it called INCOSI, and there's a lot of local chapters, including in Germany, by the way. And I think there's an environment with around 10,000 interested people in it, and a lot of people using it for really sophisticated designs as well. So a lot of people use it, but it's difficult to put a number on it. It's well known, and you can, like I have, you can pass an exam and you can get certified at different levels. So it's a very well known and highly recommend that you join it. It's a non-profit organization, by the way.
Nice. Okay. Second question: how much is RDS? Or we've learned the same. 81346 used worldwide?
That's also a good question. For some reason, people don't want to be the first movers.
Yeah,
right?
yeah, exactly.
Is everybody else? I'm the only one. I think I've been working with this standard for 25 years now, and the thing is that every day I work with it, I still learn something new. So it's an endless story. So just like playing music, you get better and better, find details and things in it. And what we have seen the last 3-4 years, especially by introducing the triangle and the system of aggregation and the easy pattern recognition, is getting more and more momentum. So just for the last 2 and 3 years, civil aircraft has joined into the group to use RDS.
Okay,
oil and gas business, the power sector, and a lot of other industries are getting more.
Machine builders.
Yeah, machine builders and so on, public supplies. So I think the standard and especially because we work so hard to make it relatively easy to adopt, is getting more and more momentum for the moment and getting more and more important. Interesting.
I think also for our participants. Yes, I have a look for our next question. Yeah, I think that is also interesting, especially for me. How do you convince others, my colleagues, to switch towards system thinking?
That's a tough one, huh?
Yeah?
Yeah. That's actually one of the things we do in our company as well. One thing is to have a good idea and trying to convince people. How do you convince people about that? I would say what you don't do. You don't try to bulldoze it out in your organization and say, this is a new great thing and everyone should just work like that and then everything is fine and your big PowerPoints and things like that.
Yeah.
Don't do that. We need to do something else where you actually create a requirement from the organization to get a thing like that. And the way we work with it is that we try to, we're actually very focused on creating a small project that is a success and keep it secret. Keep it a little bit secret in the organization, because that very often creates a question or a debate in the canteens. Mm-hmm. And so people start to hear about this new thing coming up and they want to join. And when they want to join, it's very important that when they want to join, it has to be easy for them to join. And then, slowly you can actually get the momentum. And suddenly things goes very, very fast.
Yeah.
So don't bulldoze it out, but create something secret and a success. And let the good rumor run, and then let's see if the momentum gets there. That's typically what we do.
Okay, let's call it also best practice example.
Yeah, absolutely.
And with a small group, yeah.
Examples are fantastic. You need fantastic, good examples to support it for sure.
Okay. Nice. Thank you. Really nice questions. And yeah, again, it was a pleasure, Hendrik.
My pleasure.
Thank you for having me here. and
Thank
have
you.
a nice day.
You too. Thank you very much.